Hello, this is 6.5 volume conversions of gases. So here we are going to convert moles to volume, given that you are going to find the volume of a gas that is at 0 centigrade, which is called standard temperature, and 1 atmosphere, which is called standard pressure. You can also convert volume to particles and mass and moles based on this system like before. So here is where we are in the scale of the topics, and to show you where we are in the concept map, we are in this section. So we can convert volume of a given substance in a balanced equation to its moles and then to the moles of the other thing, or the mass, number of particles, or volume using these three factors. So this is the factor we are going to learn today. So we are going to look at 4 types of problems. The first one is a volume to moles conversion, followed by a volumes to particle. Third one will be a volumes to mass, and the fourth one will be volume to volume, where you will have the same factor twice but flipped on the two ends. Okay. So how do you do these conversions? Again, you balance the equation just like before, and then you have to look into the problem and see if it's talking about the standard temperature. And so standard temperature is either 0 centigrade, also in a different unit, it's 273 Kelvin. Sometimes I may write 273.14, which is more precise. You guys remember just 273. Now that you have to memorize. The standard pressure is 1 atmosphere. It's a pressure unit. And so under STP, standard temperature and pressure, 1 mole of any gas occupies a 22.4 liter volume inside a closed container. I need you to remember this. So when the volume of a gas is mentioned at STP, then only then can you use the 1 mole is equal to 22.4 liters conversion factor. Then you do the rest just like before. So let's look at a problem. So if there are 4 moles of NH3 gas, ammonia gas, in a container, calculate the following volumes and moles. Volume at standard temperature and pressure. You know that if it's 1 mole, it's going to be 22.4 liters, so this will be 4 times that. And the volume at 29 centigrade and 1 atm, how will you do that? Yes, you can't calculate it because this is not standard temperature. Remember that some problems I will ask you the wrong temperature or the wrong pressure and ask you to calculate the volume, and then you just cannot. So let's go to part 1, moles to volume conversions. Here is my problem. Calculate the a chemical reaction with H2 gas and N2 gas is carried out at 0 centigrade and a pressure of 1 atmosphere. So this is STP inside a sealed container, and here is your reaction. And you're going to balance it, and you are supposed to calculate the volume of ammonia needed produced from 20.75 moles of nitrogen gas. So you're going to first start with the given value. You need to cancel moles of nitrogen gas, so you put moles of nitrogen gas here, and you have to go to the other thing, which is this guy. So you're going to put the mole-mole ratio, and then you need to cancel moles of ammonia, so you put moles of ammonia at the bottom, and here you put 1 mole of ammonia is equal to 22.4 liters. And then you can cancel moles of ammonia, and your answer will be this much. And it's going to be 929.6 liters of nitrogen ammonia. Let's look at another question. So this is part 2 of the same question. How many moles of nitrogen gas is needed to react with 200.52 liters of H2 gas? You're going to start with the given value, like so. You need to cancel liters of hydrogen. So you put liters of hydrogen at the bottom, and what goes with that is 22.4 liters, which is equal to 1 mole of H2. You need to cancel 1 mole. So here is where you put the mole ratio of ammonia to hydrogen. Hydrogen is 3 and ammonia is 2. Sorry, my mistake. You're supposed to do nitrogen gas, so it will be 1 mole right here. And then you can cancel hydrogen moles, and here is your answer. You just fish out the numbers and do the calculation. This is just like before, just you use a different factor. Now let's look at volume and particles and volume and mass conversions. The first one is asking how many N2 molecules are needed to make 12.5 liters of ammonia gas. So you're going to start with the 12.5 liters of ammonia gas, and you're going to put 22.4 liters of ammonia gas at the bottom over 1 mole of ammonia gas. These two cancels out, and then you put moles of ammonia here. You're going to put moles of ammonia and moles of nitrogen on top. And then you have to go to molecules. So you're going to convert moles of nitrogen into molecules. 1 mole nitrogen is equal to 6.022 times 10 to the 23 molecules. And the nitrogen moles cancels out. You fish out the numbers on the top, and this is what you get. And the answer is 1.68 times 10 to the 23 molecules of nitrogen. Let's look at a mass calculation. So calculate the mass of ammonia gas produced from 2.93 liters of nitrogen gas. So whenever I say mass, you have to find the molar mass, right? So you're going to find the molar mass. Nitrogen is 14 grams per mole, so you have 1 mole, that means 14. And hydrogen is 1 gram per mole, you have 3 moles, so that's 3 grams. When you add them together, you get 17 grams per mole. So then you start your calculation with the given value, this one. And then you put 22.4 liters to cancel liters of nitrogen over 1 mole of nitrogen. Then you put moles of nitrogen over here. This is where you go to the mole-mole ratio between the two things. 1 mole nitrogen gas over 2 moles ammonia. Then you cancel out nitrogen gas. You need to cancel ammonia moles. You want to go to ammonia particles. So you're going to put 1 mole of ammonia is equal to, not particles, grams, 17 grams of ammonia. Now moles of ammonia cancels out, and you have grams of ammonia on the top. And you fish out these numbers and you multiply them and then divide them by 22.4 liters. You get this gram amount. So that is your answer. So last part, volume to volume calculations. The last question is asking how many liters of hydrogen gas is required to produce 2.73 liters of ammonia. So it's between this one and this one. You're going to start with the given value, and then you multiply it by a factor with 22.4 liters of ammonia at the bottom and 1 mole ammonia at the top, so you can cancel liters of ammonia. Then in the next factor, you'll have to have moles of ammonia at the bottom, and you are going to go to the moles of the other one to the moles bridge from the balanced equation. And this one will be 2 and this one will be 3. Moles of ammonia cancels out. You need to get rid of moles of hydrogen and go to volume of hydrogen. So then you have to multiply by this factor, and then moles of H2 cancels out. You fish out the values and you multiply these things on the top by the two numbers at the bottom, and then you divide them by each other. You get 4.1 liters of H2, and that's it. So these calculations are exactly like what you did before. Only thing is you have a different factor. 1 mole is equal to 22.4 liters of a gas at standard temperature and pressure. So let's look at how to do these calculations, a review. And that is it for now.